Welcome to Echo 315, Study Session 7, Valuation Principles in Finance, Compounding and Discounting. Introduction. Time value of money is a critical consideration in financial and investment decisions. You need compounding techniques to determine future sums of money resulting from an investment, while you need discounting techniques to evaluate future cash flow associated with capital budgeting projects. In this study session, we will examine the calculations and applications of compounding and discounting techniques. Learning outcomes. When you have studied this session, you should be able to 1. Apply compounding and discounting techniques in resolving financial problems involving annuity and sinking funds. 2. Discuss how effective compounding technique is in resolving such amortized loans problems. Compounding interest. A naira in hand today is worth more than a naira to be received tomorrow, because the interest you could earn by investing it. Compounding interest means that interest earns interest. You can calculate the future value of an investment compounded annually at the rate I for n years. That is F divided by P I N, as Fn equals P into bracket 1 plus I to power n, which equals P asterisk FVIF at the rate of I and in n years, where Fn is the future value of amount P at the end of year n, P is the principal, R is the annual interest rate, N is the number of years, FVIF IN is the future value interest factor of 1 naira. For example, you will calculate the future value of 1,000 naira at 10% annual compound interest at the end of 3 years as F3 equals 1,000 of 1 plus 0.1 in bracket to power 3, which equals 1,000 times 1.331, which gives us 1,331 naira. If the interest is compounded more than once a year, the formula P of 1 plus I over M in bracket to power N asterisk M, which equals P asterisk FVIF I M N M, where M is the frequency of compounding per annum. Example 1. You will calculate the future value of 1,000 at 12%, that is compounded monthly at the end of 3 years as F3 equals 1,000 of 1 plus 0.12 over 12 in bracket times 3 asterisk 12, which equals 1,000 times 1.4307, which gives us 1,430 naira 0.7. If the interest rate is compounded continuously, M approaches infinity, and the formula becomes Fn equals P asterisk E to power I asterisk N. For example, you will calculate the future value of 1,000 naira at 12%, that is compounded continuously at the end of 3 years as F3 equals 1,000 E to power 0.12 asterisk by 3, which equals 1000 times 1.4333, which equals 1433 naira. Future value of an annuity. An annuity is a series of equal payments made at specified intervals. Interest is compounded on each of these payments. Annual payment can be made at the beginning or the end of the specified intervals. If they are made at the beginning of the period, the annuity is called an annuity due. And if the payment is made at the end of the period, it is called an ordinary annuity. You could assume ordinary annuity unless the question specifically states otherwise. The future value of an annuity is the sum of all period payments plus the interest that has been accumulated on them. You can calculate the future value of an annuity at rate I for n years. Sn equals A times 1 plus I in bracket to power n minus 1 over I, which equals A asterisk F V I F A, where Sn is the sum of value of an n year annuity, A is the amount of an annuity, FVIFA in IN is the future value interest factor for an n year annuity compounded at I percentage. Example 7.2. If you deposit 1,000 naira at the end of each year for the next 6 years with annual interest rate of 8%, we can calculate the total value of your money at the end of 6 years as S6 equals 1,000 bracket open 1 plus 0.08 bracket close to power 6 minus 1 divided by 0.08, which gives us 1,000 times 0.586874 divided by 0.08, which gives us 1,000 times 7.335929, which gives us 7,336. Discounting present value. Present value is the present worth of future sums of money. The process of calculating present values or discounting is the opposite of finding the compounded future value. In connecting with present value calculations, the interest rate is called the discount rate. You can calculate the present value of an amount receivable or payable at the end of nth year when discounting at I percentage per annum as PVN equals F times 1 plus I in bracket to power n, which equals F times PVIF, where PVN is the present value of an amount payable at the end of nth year for n years, is the discounting factor for 1 naira payable at I interest at the end of nth year. Example 3. If you can earn interest at 10% on your investment, the present value of 20,000 naira that you receive 6 years from now can be calculated as follows. PV6 equals 20,000 times 1 plus 0.1 in bracket to power 6, which gives us 20,000 times 0.5645, which gives us 11,290 naira. For streams of cash flows, The present value will be the sum of the present value of each individual amount. It is easier to tabulate the calculation of present value that involves streams of cash flows. Example 4. For example, assume that you received your 20,000 over the next 6 years as follows. Year 1, 1,800. Year 2, 2,500. Year 5, 4,000. Year 6, 5,000. Total 20,000. You can calculate the present value as follows. Year 1, receipt 1,800. Discounting factor at 10%. 1 plus 0.1 in bracket to power 1, which gives us 0.909091. Present value 1,636.364. Year 2, receipt 2,500. Discounting factor 10%. 1 plus 0.1 all in bracket to power 2 equals 0.826446. Present value 2,066.116. Year 3, 3,200 as receipt. Discounting factor at 10%. 1 plus 0.1 all in bracket to power 3, which equals 0.751315. Present value 2,404.207. Year 4, 3,500. Discounting factor 10% equals 0.683013. Present value 2,390.547 naira. Year 5, 4,000 naira as received. Discounting factor 10%. 1 plus 0.1 in bracket to power 5, which equals 0.620921. Present value 2,483.685. Year 6, 5,000 as received. Discounting factor at 10%. 1 plus 0.1 all in bracket to power 6, which equals 0.564474. Present value 2,822.37. Total receipt will give us 20,000, and then total present value will give us 13,803 naira 0.29. Present value of annuity. This is the value today of a series of equal payments or receipts to be made or received on specified future date. Interest received from bonds, pension funds, and insurance obligations all involve annuity each. You can calculate the present value of an amount receivable or payable at the end of each of the next n years when discounted at I percentage per annum, that is P over A at I interest rate for n years, as Pn equals A bracket 1 minus 1 plus I in bracket to power n divided by I, which equals A times PVIFA at I interest rate for n years, where Pn is the present value of an amount receivable at the end of each of the next n years. PVIFA is the annuity discounting factor for 1 naira annuity discounted at I percentage for n years. Example 5. Assume, for example, that you are offered an investment that paid 1,000 naira a year at the end of each of the next 3 years. We can calculate the present value of the investment if you desire a return of 6% as follows. P3 equals 1,000 bracket 1 minus bracket 1 plus 0.6 bracket close to power 3 divided by 0.6, which equals 1,000 times 1 minus 0.839619 divided by 0.06, which equals 1,000 times 0.160381 divided by 0.06, which equals 1,000 times 2.673012, which equals 2,673 naira. If the annuity goes on forever, it becomes perpetuity, and the present value becomes P infinity equals A divided by R. For example, if she will receive 1,000 forever, the present value becomes 1,000 over 0.06, which equals 16,667 naira. Deposit to accumulate a future sum. Sinking fund. In a sinking fund, you invest an equal amount annually. The investment earns compound interest at a specific rate. You expect the investment and the compounded interest to accumulate to a specific amount. You can calculate the annual deposit that is necessary to accumulate a future sum in n years' time at high interest rate as sinking fund equals S of n over 1 plus I, all in bracket, to power n minus 1 divided by I, which gives us Sn divided by FVIFA at high interest rate for n years. Example 7.6. Fleming Limited issued 100,000 8% debenture in 2000 with condition that a sinking fund be set up for its redemption 5 years later. The sum to be set aside every year should be such that when invested annually at a compounding interest rate of 12% per annum will amount to 120,000 naira at the due date of redemption. You are required to determine the appropriate amount to be transferred to sinking fund account annually. Sinking fund therefore equals 120,000 naira divided by 1 plus 0.12, all in bracket, to power 5 minus 1 divided by 0.12, which gives us 120,000 divided by 1.762342 minus 1 divided by 0.12, which equals 120,000 divided by 6.3525, which equals 18,890 naira. Amortized loan. An amortized loan is a loan that is to be repaid in equal periodic amounts. Examples include vehicle loans, mortgage loans, and most bank loans. You can calculate the periodic payment to repay an n-year loan PN at high percentage interest rate as loan repayment amount A equals PN divided by 1 minus 1 plus I bracket to power n divided by I, which equals Pn divided by PVIFA at I interest for n years. Example 7. The required monthly payment to repay a 40-month vehicle loan of 500,000 naira at a 12% annual interest rate will be calculated as follows. Monthly repayment amount A equals 500,000 divided by bracket 1 minus bracket 1 plus 0.1 divided by 12 bracket close to power 4 divided by 0.12 divided by 12. Monthly repayment amount A equals 500,000 divided by bracket 1 minus bracket 1 plus 0.12 divided by 12 to power minus 40 bracket close divided by 0.12 divided by 12, which gives us 500,000 divided by 1 minus 0.671653 divided by 0.01, which equals 500,000 divided by 32.83469, which gives us 15,228. Thus, each loan payment consists partly of interest and partly of principal. The breakdown is often displayed in a loan amortization schedule. The interest component is largest in the first period and subsequently declines, while the principal portion is smallest in the first period and increases thereafter. Effective annual rate, annual percentage rate. It is clear from our previous examples that different investments use different compounding periods. Some semi-annually, others quarterly. If you wish to compare investment with different compounding periods, you need to put them on a common basis. This common basis, which is the annual equivalent, is referred to as annual percentage rate or effective annual rate. The formula for calculating the annual was 1 plus R over M, all in bracket, to power M minus 1, where R is the stated or nominal or quoted rate, M is the number of compounding periods per year. Summary. In this study session, you learned how to use compounding and discounting techniques in solving financial and investment problems like annuity, sinking fund, amortized loan, and annual percentage rate. The process of calculating present values or discounting is the opposite of finding the compounded future value. Do not forget that for streams of cash flows, the present value will be the sum of the present value of each individual amount, and it is easier to tabulate the calculation. This is the end of study session 7. Thanks for listening.